We'll look at a few more examples here. And we see that there's a typo here. Well, let's fix that. The independent variable of this function is actually t. It's not supposed to be x. So let's fix that right away. That's supposed to be a t. And we're going to go ahead and check the form for this function. We're going to check the numerator. As t approaches 2, what would the numerator approach? Let's see. Looks like it will approach 0. Okay, so it's approaching something very small. So we're going to indicate that with a 0. And the denominator is also approaching 0, or it's approaching something very small. So we have very small over very small. This is an indeterminate form. Indeterminate form. Okay, you don't know what this limit's going to look like. More importantly, you cannot write limit laws at this step because you have 0 in the denominator. So what we have to do is resort back to algebra. Let's see if we could react to the numerator with some algebra. So our reaction to the numerator here is actually going to be something called factoring. And factoring is very key, one of the more important topics of algebra. And remember, with factoring, you finish factoring by checking. So make sure you check that your factors are indeed correct. We're also going to factor out a -1 here in the denominator. And so we see that we get a factor of t minus 2. Now we can notice common factors. Common factor is t minus 2. So this will now simplify to the limit as t approaches 2 from both sides of this polynomial. Now, because this is a polynomial, we're ready to evaluate. So we get -5. So this is the evaluation of this particular limit. Notice we could not write limit laws right away. Instead, we resort back to algebra to help yourself. Let's look at a couple more examples. Once again, we'll check the form. We have more limits that involve fractions. So as x approaches 0 here, it looks like we have a over a, and then over what? Over 0 quantity squared. So once again, this is an indeterminate form, 0 over 0. That means we cannot write limit laws. All right. So what we're going to do is we're going to resort back to algebra. We're going to do a technique called multiply by the conjugate. So we're going to use some magic here. Another word for magic is simply algebra. And we'll use this algebra and see what we get. So the numerator is fascinating. The numerator is actually just an x squared. And we're going to go ahead and keep simplifying using our algebra. Simplify any common factors. We do have one. X squared over x squared is in fact equal to 1. So we're left with 1 in the numerator. And we're left with this function in the denominator. Now let's check its form. If you check its form at this point, we get what? 1 in the numerator, and we get a plus a. Now, a is a finite number. As long as a is not 0, okay? As long as a is not 0, we're okay. Gotta make sure a is not 0, and it's probably not 0. We're ready to evaluate this limit. If you wanted to, you could write limit laws here. The independent variable is x. And notice we finally get the quantity or the expression 1 over a. As long as a is not 0, this is true. So the evaluation here is a little bit more involved. Make sure you're able to write all these steps, know exactly when to write LIM, and know exactly when not to write LIM. That way you get practice of this technical writing involving limits. Example 8, go ahead and check its form. You gotta think 2 steps ahead. So think of the numerator. The numerator looks like 4 minus 4, which is 0. And then the denominator is approaching 0. So this really looks like 0 over 0. And that is an indeterminate form. So we're going to go ahead and apply the technique called multiply by the conjugate and see where this takes you. Much of calculus is just algebra. So the more algebra you know, the more calculus you can study. Simplifying the expression in the numerator. We see an h. Keep simplifying. Keep relying on some magic. Just gotta write it out. And finally, we get to a new fraction where we want to check its form. Let's check its form. The form is what? 1 is always in the numerator, and now we got 4 plus 4. 4 plus 4 is about an 8. Okay? Or I should say 4 plus 4 is 8. Well, that's a determinate form. So now you're able to write limit laws. Not a lot of thinking, but just a lot of writing. And notice the solution isn't just 1/8. The solution here is all the algebra involved and all the LIMs involved. Know exactly when to write LIM and know exactly when not to.